Hello, everyone. My name is Jinghui Qin, one of the HPC technical consultants in Sharcnet and cited at Western University. So today I'm going to talk about running JupyterLab on Nibi clusters, the newly available cluster replacing the previous Gram cluster. So it is operated and managed by the Sharcnet team. JupyterLab provide a web-based interactive environment for notebooks and code development. It is commonly used in data analytics, for example, to visualize data, to test a code block, or go through a self-explained tutorial notebook, and etc. JupyterLab also supports different programming languages and application tools when additional kernels or extensions are added. But today, I will mainly focus on running JupyterLab in Python on the Nibi cluster. Okay, let me start with this picture to give some general information about working on a cluster. So we have 5 major clusters across the country in the Digital Research Alliance for Canada. So Nibi is one of them, which is located at Waterloo University and managed by the Sharcnet team. So this picture illustrates working on a cluster. For example, on the most left side here are users on their local computer, and the rest is the remote cluster, or you can call it a supercomputer, which consists of some logging node and many compute nodes, and the disk for storage that is mounted on logging node and compute nodes, which provides a cluster with a consistent file system access on all nodes. As you can also see here, users cannot directly access those compute nodes. Users can only access the logging node. Okay. The common way to access the compute resources on a HPC cluster is through SSH, a secure shell through command line on a Linux terminal to connect to a logging node. Okay, so jobs to run on the cluster are requested and managed through a batch system with a job scheduler instead of running directly on a logging node. Okay, so job scheduler decide where and when to run your job on the compute node that have the resources you requested. Okay, since JupyterLab was implemented as a web application, which is connected using a web browser. So in order to make use of the compute resources on a cluster, a Jupyter server needs to run on a compute node that have the resource you requested. However, using a web browser on your local computer to connect to a Jupyter server that runs on a compute node, it usually requires to set up a secure tunnel through the logging node, so which is inconvenient for most users. Okay. But since the Jupyter Hub has been deployed on a cluster, it provides a quick start option of launching and connecting JupyterLab on a cluster. So Jupyter Hub is provided as a web portal that users can access simply using a web browser. Okay. So it automated the procedure of launching JupyterLab on a cluster, including sending a request to the scheduler and then launching JupyterLab server on a compute node with a pre-configured environment, then connecting to JupyterLab directly in the same web browser. It is very convenient. However, there are still some limitations to work with such pre-configured environment. And for some cases, it is still unavoidable to work with command line And in some cases, you can only work manually on command line, for example, through SSH. Okay. So with the new cluster Nibi in production, an alternative way to access compute resources on Nibi cluster is available. That is Sharcnet OnDemand web portal. Okay, so Sharcnet OnDemand web portal provides an integrated access to the compute resources on the Nibi cluster using a web browser, similar to JupyterHub, but with more functionalities. So with the Sharcnet OnDemand, it is not necessary to use additional tools other than just a web browser to access and work on the Nibi cluster. So thanks to Sharcnet staff member, my colleague Tyson Whitehead, who made this option available. Tyson also provided a webinar to introduce this web interface to access a Nibi cluster a couple of weeks ago. And the video recording is available on Sharcnet YouTube channel. Okay. So one of the features with the Sharcnet OnDemand is that you can request an interactive session on a compute node, okay, and interactively work on the compute node with a graphical desktop interface on the Nibi cluster. So here are more information about access Nibi. So Nibi provides around like 140,000 CPU cores and about 300 GPUs, including NVIDIA H100 GPUs and AMD MI300A GPUs. So very powerful resources and 25 petabyte of storage in total. So after you log into Sharcnet OnDemand dashboard, also ondemand.sharcnet.ca, so you will see such dashboard. So with this File tab, it allows you to access the files, folders in your home directory on the Nibi cluster. So you can upload, download, edit, or create, or delete files in your account on Nibi. And that means you can just use a web browser to access and manage your files on the Nibi cluster. Okay, with this login node tab here, it provides you access to a login node with a command line terminal, okay? Similar to what you usually do through SSH, but this is done in the web browser. So you can run commands to compile your code, submit your jobs, and do anything you normally do in the command line on a login node, okay? So here, the compute node, it allows you to request for an interactive session on a compute node, okay? So this is particularly helpful for running application or jobs that involves some graphics and require user interactions for development or testing with the compute resources on the clusters. So for example, running MATLAB or JupyterLab, RStudio, and etc. Okay, so various application sessions can be made available through Sharcnet OnDemand. So at the time when I started preparing this webinar, only a Nibi Desktop session is available that you can request. And my original plan was to show you how to run JupyterLab on Nibi Desktop, which provides you with full flexibility to run JupyterLab in your preferred environment. But last week, Tyson also made a Nibi JupyterLab session available under this tab. So you can request from Sharcnet OnDemand. So for those of you who are familiar with launching JupyterLab from JupyterHub portal, so which was previously available on Gram and some other clusters, the good news is that a Nibi JupyterLab session from Sharcnet OnDemand provides exactly same pre-configured environment as the one from JupyterHub. Okay, so which serves you as a quick start option of launching and connecting JupyterLab on Nibi. Okay, I will show you both of the options, and you can decide which one you to suit your specific use case. So you will see Sharcnet OnDemand provides a more integrated access to the cluster. Okay. So here, option 1, request a Nibi JupyterLab instance, okay, which is the same as from JupyterHub. So if you're familiar with the previous JupyterHub or you want a quick start, this is the option to use. So when you log into Sharcnet OnDemand portal, click Compute Node, and then select Nibi JupyterLab. It will bring you to this kind of form for you to fill up with the resource details you want to request for this session. For example, your account name, how many cores, amount of memory, number of hours, and you can also put your email there, so to receive a notification when the session started. Then you click Launch to submit the request to the job scheduler on Nibi. So it will show you your request status from queued to start and then to running. As the screenshot showing here, it is running, and it's also give you the compute node host name and some other information, tell you how many time, the time remaining for this session. Yeah, you can then click connect to JupyterLab to connect to the Jupyter server in your web browser. It will open into another tab in the same browser, okay? And this is a familiar interface if you previously worked with a JupyterHub, right? So on the file browser panel, it will list all your files, folders in your home directory on Nibi. And the launcher panel, as you can see with this updated version of JupyterLab, it also provides some apps that you can access from JupyterLab's launcher portal. For example, if one wants to work with R in RStudio, so you can just click to launch RStudio from here. And another example would be VS Code, yeah, if anyone wants to do that. So one thing to note here is that the pre-configured environment is not persistent because it was configured on the local disk of the compute node where Jupyter server runs. So everything you installed from your notebook, for example, you do pip install on my notebook. So those environment was on the local disk of that compute node. That means it will be purged once the session is done or times out. That means every time you start a new JupyterLab session, you will need to install all the Python libraries that are required to run your notebook. Okay, the environment is not persistent. Yeah, same as the previous JupyterHub. Same feature here. But it gives you a quick start and also with some default applications from the launcher panel here. Option 2 is to start a Nibi Desktop. This is the option I suggest to use if you prefer work with a customized environment instead of the system pre-configured one. For example, if you would like to work with a self-built Python virtual environment or run notebooks with a container-based package, for example. Okay, to request a Nibi Desktop instance, you simply click Compute Node tab and then select Nibi Desktop. It brings a similar form for you to fill up with the resource details, the CPU cores and hours and count information. Then you click Launch to submit the request to the job scheduler on Nibi, and similarly, it will then show you your requested status from queued to start and to running. As the screenshot show here, it's running with the host name of this compute node that this desktop runs on. Okay, so then you can click Launch Nibi Desktop to connect to the desktop. You will see a Linux graphical desktop appears in your web browser. This is where you can work interactively on that compute node. Similar to working on your local computer, but this is a remote compute node on the cluster with the CPU cores and the memory you requested. Okay, that's very nice. Then how to launch JupyterLab on the Nibi desktop manually, okay, because we only have a desktop. To work on a project in Python on the cluster, the rule of thumb is to prepare a Python virtual environment with required Python libraries installed. So same rule apply for launching JupyterLab to run Python notebook. Okay, so on Nibi desktop, you open a terminal to prepare a Python virtual environment with the required Python library installed. And don't forget, also install JupyterLab, since we're gonna work with the JupyterLab, right? So you need to also install JupyterLab in the same virtual environment with all the other libraries as well. Then to launch JupyterLab from that terminal window, we want to set the home directory as the root directory so you can find or access any files or folders in your account from JupyterLab. Okay, so here are the example steps. Okay, you just load the Python module or any other modules and any other module if needed, create a virtual environment if you don't have an existing one. Okay, if you already have an existing Python virtual environment you prefer to work with through JupyterLab, you simply need to activate that environment and do pip install JupyterLab. Okay, if it's a new, and then you just install JupyterLab along with all the other Python libraries. Okay, then this is the command to launching JupyterLab from this virtual environment. Yeah, you put a notebook directory as a home, so it will get your home contents listed, so you can find any files or create any file anywhere through the file browser there. So it will display the URL of the JupyterLab and trigger Firefox, the default browser on the desktop, to open and connect to this URL. So this is what it look like. Okay, you open a terminal window. You can from application, you click, there is a system tool, and then select a terminal. Yeah, open a terminal window. And then, run the command I showed you in previous slide, and then you will see such JupyterLab open in a web browser. It's Firefox. So if you didn't provide that root directory as home, it will just show the directory. It will just show the directory in which your JupyterLab command runs. So yeah. Okay. This is the option 2. Okay. So next, I'm going to demo on Nibi through Sharcnet OnDemand. I have 3 use cases prepared to demo both options. Okay, so for case 1 is to work with a pre-configured JupyterLab. That's a Nibi JupyterLab instance. Okay, connects through that JupyterLab, and then run a tutorial notebook for image classifications. And we can install some Python libraries, for example, TensorFlow, Matplotlib from a notebook interface. So this case is to demo a quick start of working with a pre-configured JupyterLab. Yeah, similar as from JupyterHub. And the pre-configured environment is not persistent, yeah, as I have mentioned. Okay, so let me see, exit full screen. Yeah, so this is our Sharcnet OnDemand at ondemand.sharcnet.ca. After you log in, you see this. So from here, you can just select the Compute Node tab, select Nibi JupyterLab to work with a pre-configured JupyterLab. Okay, you can put your account information. Yeah, if CPU, you work with the CPU, you just put here and fill up all your requests and then start with launching. Okay, if I click launching, you see this request is queued. So it means either your priority is low or the resource you want is not available, it will queue, but it will becomes running and send you notification in email. Okay, so for this demo, I already have one created, as you can see here. This is Nibi Desktop, a JupyterLab instance. Okay, this one is running with the resource I requested. I can just click this one. It's very similar. You submit the job on the cluster. Okay, so once connected, you see in the same web browser, this JupyterLab is running on this compute node, G22.nibi.sharcnet. Okay, with the resource here, I have 8 core, 32 gig of memory, and 1 GPU, H100 GPU. That's the resource I requested when I filled up that form. Okay. So here we have 5 browser. You can find your home contents. My demo notebook is in here. Okay, case 1, I think. Yeah, so on this launcher panel, for example, if you would like to work with RStudio, you click, it will brings up this RStudio you can work with on that compute node. But this is accessed through your web browser, so that's convenient. Let me close that. And yeah, there are some others. So for this demo notebook, I will just open here. Okay. This is an example notebook from NVIDIA Deep Learning Institute. It's kind of a hello world example for deep learning, okay, for image classification with the MNIST data set. Okay. So on the sidebar here, this pre-configured JupyterLab, you can also access, for example, this tab show you the system module. If you need any, you can just load module there. These are the current loaded module by default. But if you need any other module, you can find from here. And another thing to mention is that this is also have a GPU dashboard. So for example, we can check, GPU utilization or monitor GPU usage. Okay, so now this, we don't have anything run here yet. So this is a NVIDIA H100 GPU. So yeah, let's see. For this notebook, it requires to have some, these two libraries, TensorFlow and Matplotlib, to run this notebook. Okay, I won't go through detail, just show how to run this. For example, in this default environment, if you simply just type import Matplotlib, it will say it's not available. So to get it installed, because both Python wheels are available on the system. So you simply need to do pip install with the -- no index. So it will just pull from anything available on the system. Okay, so we just run this command to have it installed. It will take some time. Yeah, so then we just quickly go through what included in this web. Yeah, it will do some exploration on the available data set, and this the data set, and then preparing the data for training. Yeah, flatten the data and normalize the data and do some categorical encoding. Yeah, it's a tutorial. JupyterLab, or just show you what's included here, and create a module, or create a deep learning model with TensorFlow. Yeah, it's a sequential model. Then you add more layers, like there's a dense layer, I think 2 dense layer, and then create output layer, and then you do the training with MNIST data set for image classification. Let's go back, see if the installation completed. Let's see. Okay, it's completed. When you see a number showing here, that means this command is completed. So at the bottom, yeah, anytime when you complete the installation, so many things installed, you see, you may need to restart. It says you may need to restart the kernel to use this updated package. So we just restart, select this, restart the kernel. So to make all of the library you just installed then becomes effective. Okay. Okay, once we did that, then we can just run, select the cell. We'll just run all of them at once, okay? So yeah, it starts running now. It's showing, it's already to this fitting steps. So yeah, the summary is here already. We can also see the Jupyter memory. Oh, you see the loaded here. And the fitting will start it because it's compiled model. It's doing the job on the GPU. You see, you can see the GPU utilization here. Yeah, because this is just a small example for demo, so won't use a lot of resource on GPU. Okay. Yeah, so it's running. If you see it stop, then okay, I think that's all. Yeah, it's already done. See, yeah, you can check, observe the accuracy, and there are some, exercise. See the accuracy, I think it's displayed here for 98%. Okay, yeah, this is case 1 to show you the quick start with a pre-configured JupyterLab. Okay. I just remembered the next time if you request a new session, the library, you have to reinstall it again. Okay. Okay, let me just close this. Okay, we don't need this. Yeah, if you want to shut down all the kernels, you just select the second tab here to shut down. Okay, so we can close. You see, this web browser is your local desktop browser. Okay, we just turn off this. Yeah, and then we continue our second use case to work with a self-built Python virtual environment on a Nibi Desktop instance. And after we connect to Nibi Desktop, we're going to run an example notebook with a commercial software called Groovy. So Groovy is available on the system. You see, we have a wiki page to have more information. It is a commercial software suite for solving complex optimization problem. It requires a license, but a free license is available on the system, but you need to send this academic usage agreement before you are able to access the free license for academic usage on the cluster. Okay. The demo example is from Groovy GitHub. In this example, the goal is to assemble a best team for a basketball game based on each player's previous performance and some other constraints, for example, a player's position in the game and the overall financial budget and etc. Okay, but anyway, this example is one of the example to demo how to combine machine learning and mathematical optimization using Groovy. Okay. To run this notebook, you see here, it lists all required Python libraries: pandas, numpy, matplotlib, seaborn, and scikit-learn. All these are already available on the system. You can just make them installed in your Python virtual environment. Yeah, you need to prepare a Python virtual environment. And the Groovy. For the Groovy, we have a special instruction here how to install Groovy with Python, because Groovy package also support other programming language like C, C++. But working with Python, you need to follow this instruction. Request a license first, okay? But anyway, so you prepare a Python virtual environment with all these library installed. And don't forget to include the JupyterLab as well, because we're gonna use the JupyterLab to run the notebook, okay? Then we launch JupyterLab from a terminal on the Nibi Desktop, as I showed you in previous slides. So in this example, I'm going to show the full flexibility to work with a customized environment. So the environment can be persistent in your account as long as your virtual environment is created in your home or project space, right? Okay, let's go back to here. So from the compute node tab, you see, you can request a Nibi Desktop with a similar form you select, and then you click launch. For example, if I click this, it will say Nibi Desktop queued, yeah, with the request detail. So it will send a notification email. Oh, it's running. Okay. That's nice. We can just use this one then, because I already have one reserved earlier. So, okay, let me just connect this one. It's just available. You see, it brings you this desktop on that compute node in your local web browser. It's very nice. So from this application tab, you can select system tool. You see, I would like to use this terminal. Okay, yeah. So this brings up a terminal window. You see, it's my home directory with all these files. So I can just go to my project and go to Jupyter demo for case 2, I think. Okay. Yeah, this is my contents. I can make it larger, maybe. Okay. Yeah, I already have a virtual environment created. When I created that virtual environment for this particular software package, it requires to load the Groovy module on the system because the Python just Python API access the tools. So all I need to do module load Python and Groovy. Okay, those two modules are necessary to be loaded before you activate your Python virtual environment. Yeah, any system module, if required for your when you create your Python virtual environment, you need to load the system module first before you activate your virtual environment. If you load the module after your activation of a virtual environment, the system path won't set properly. Okay, so you have to load any system module if needed before you activate your your Python virtual environment. Okay, from here, if I can, you see, I already have Groovy Py available. Oops. What is Groovy Py? Maybe. Yeah.
PP list.
Oh, sorry. Thanks. Oh. Hmm? Pip list. I just list all of them. And yeah, that's all. See, you see, I already have JupyterLab, all the contents also included. So I'll just show you, sorry. To launch JupyterLab. If without put the home, to show the home, I mean, so no work ERR home. It will just show the contents of the current folder. Okay. You see, it brings up this. Okay, you go to here. Oh, you see, you can access home. Yeah, the home is here. It's here. Or because we had the previous working with that JupyterLab instance, it will cache your previous activity with JupyterLab as well. So this is the JupyterLab runs on this Nibi Desktop. As you can see, we have this tab, okay. This is on the JupyterLab instead of on the Nibi Desktop. So it's not in the same browser of this local browser, okay? And we can select the file from that directory. I have case 2 example here. This is the notebook I downloaded from Groovy GitHub, one of the modeling example as I showed you. Yeah, it requires to have all this Python library I already pre-installed in my Groovy environment. Okay, so you can check the current directory. That's my directory on Nibi. And we need to import all the library required. But see, it working. That means that they are all available. Okay. And yeah, same. I won't go through any details. So it will have some graphics to show and with step-by-step tutorials. So I will just run from here, I guess, from this one. To run the example, select the cell and all below. Okay. Yeah. It probably will stay in the step for fitting because it includes the machine learning part. It's still running. Okay. I see. Oh, it's already showing some result here in graphics. Yeah. Any other? Yeah, it's running. Yeah, let's see if it's been completed. Okay. Yeah, it's a tutorial notebook. If anyone want to learn how to work with Groovy with similar kind of application. Yeah. Okay, so this is to show you the flexibility of working with a customized environment. Okay. So we can save and then close this. Okay, oops. This is on the so I will just turn off this web browser. Okay, yeah. So we can Control C to shut down this server because I finished demo of this case. Okay, I will just deactivate from this environment. Let's go to case 3. Okay, so for case 3, yeah, we finished this. Case 3 is to demo running notebooks with a container. So I'll use Anaconda as an example for this case. Okay, so this kind of use case you cannot do with you cannot do with the pre-configured JupyterLab. Okay, you can only be done on command line on the Nibi Desktop. Okay, Anaconda contains more than 400 Python libraries for data science, machine learning, and AI. Okay. So if you work with data science, you probably know what Anaconda is. Okay. But on any clusters, it is not recommended to have Anaconda natively installed on the cluster because of some management concerns. So one of the suggestions is to work through a obtainer container that converted from a Docker container for Anaconda. Okay. But I have to say that most of the Python libraries included in Anaconda are already available on our system, and you can use a pip install with -- no index to install in a Python virtual environment without using a container. As this container also has a Jupyter package included. So For simplicity and the demo purpose only, I will just use this container to demonstrate how to run JupyterLab with a container on the Nibi clusters, okay? So here, I'll just show the command how you can build a obtainer container from a Docker container. Since Docker is not directly supported on the cluster, you need to convert the Docker container to an obtainer container. So you load the obtainer module, run this command to build anaconda.sif. This is the obtainer container name you gave. And here are just the URL of that Docker container from Docker Hub. Okay, so for example, this Anaconda container, Docker container is available here. You see, this is the pull tag. So you just the URL to use here, just do docker :://. Once you have this container built, and then on the Nibi Desktop in the command line to launch JupyterLab, you just access the container shell first and then run this command. Since no web browser is available in the container shell, so you need to put no browser, and then we will use the browser on the host to connect to this URL. Okay, so this is, you open another terminal on the Nibi Desktop, type this command. Yeah, copy paste that previous JupyterLab URL and then put it here to use Firefox on the host to connect to JupyterLab. Okay, so let's still use the same desktop here because I already have this container available built here. So module, I only need to module load obtainer. And then we access the obtainer shell first, container shell first, okay? And anaconda sif, okay. In this container shell, as you can see, the root directory looks like this. It's different from the host. This is the host root directory, you see. Yeah, once you're working in a container, you are isolated within that container environment. Okay, so in this container, I know, so let's check how many packages are available there. See, it's more than 500, like Python libraries available. So we can also see Jupyter. You see Jupyter is also available. So we can start a JupyterLab server here with no browser. So yeah, with this JupyterLab, you can work with all the Python library included in that container. So it's like 500, more than 500. Yeah, like a NumPy, Pandas, all of them, they are included. Okay, oops. No, is this? No? Oh, Jupyter, sorry, here. Yeah, so no browser. So we need to open another terminal. Okay, we can open a tab here and then use the Firefox on the host to connect to this URL. We need to copy this URL. Okay, localhost, that's local on the compute node. Yeah, you right click the mouse, select copy, and then in this terminal tab, you right click, select paste to a paste. Yeah. So this opens, you see the Firefox. Now you can work with this container. and yeah, this is the current root directory is the current directory from which we launched the JupyterLab. So yeah, I only show the contents here. So I have a notebook. It's simple, just demonstrate, verify what libraries you can use. So for example, you import Panda, Panda is available, and this version, and if NumPy, they're all included, scikit-learn, and the version is also available. Okay, yeah, all of them, all these are included in the Anaconda. You can work with even number. Okay, yeah, this is to demo how to work with a container. Okay, we can just don't need this. I can just close this. Okay. Leave page. Okay. So yeah, once you closed it. Okay. Yeah, I think that's all for the demo. I have another last the summary. Okay. Summary here. A web browser is all you need to work through a Sharcnet OnDemand portal. So to request a Nibi JupyterLab instance, okay, if you want to get a quick start to work with a pre-configured JupyterLab, or you want to use any application available from that JupyterLab launcher panel, for example, RStudio or VS Code. Request a Nibi Desktop instance if you prefer a full flexibility of working with a customized environment. For example, I demoed a self-built Python virtual environment or a container. Okay, and the environment can be persistent in your project space. The final note here is running JupyterLab or notebooks is meant for short interactive tasks, for example, for testing, debugging, or quickly visualize data and etc. But longer analysis should be done in a non-interactive job because the cluster is mainly supporting batch. It's a batch system supporting batch run. So you need to convert your notebook into a Python script, then submit a job script to the scheduler to schedule your Python script execution. So we also have a Docs wiki page for Python you can access to see how to prepare such a job script. Okay. And lastly, the demo example are available here. If you are interested to try it out yourself, you can get from there. Okay. I think that's all for today.